All right, we're going to look at this one, number 25. I think this is the last one in this section 5.8. We're going to evaluate this integral right here. Notice the independent variable is t. And so, what can we do here? Now, be real careful. I can't distribute the t squared inside the radical here easily enough. But I see a composition, the square root of t minus 23. So I could choose u to be t minus 23, which means the derivative, the du, would just be equal to dt because the derivative of t minus 23 is 1. So that takes care of the square root of t minus 23, which would become the square root of u, or u to the 1/2 power. dt is just du, but I've got this t squared left over. What am I going to do with that? I can't have t's and u's mixed up. Well, look at here. Since u is t minus 23, I can add 23 and get t as u plus 23, and then I can square t, right? And I get u plus 23 squared. So this is what t squared will be in terms of u. Now I'm going to go ahead and expand that out, right? If I expand u plus 23, I get u squared plus 46u plus 23 squared, which is 529. Okay, and so I'm going to replace t squared with this. All right, I just expanded. The square root of t minus 23 is the square root of u, or u to the 1/2. And as we said, the du and dt are equal this time. So how do I evaluate this integral? Well, now I can distribute. Unlike before, which it was kind of hard because I had one expression under the radical, I can now distribute, and I have what? U squared times u to the 1/2, add the exponents, I get u to the 5/2. 2 plus a half is 2.5, or 5/2. Here, 46u, u to the 1/2 gives me 46u to the 3/2 power, and then multiplying the last two gives me this expression here. All right, so finally I've got it in a form where I can find the antiderivative of each one of these with the power rule. Remember how we do that? The antiderivative u to the 5/2, add 1 to 5/2 gives me 7/2. Dividing by 7/2 is the same as multiplying by 2/7. Over here, 46, pull that out. Antiderivative u to 3/2 is 2/5 u to the 5/2. And antiderivative u to the 1/2 is going to be 2/3 u to the 3/2. Okay, so that's all by the power rule. And then just cleaning this up, multiplying the fractions I have here, and of course replacing u. Remember, u up here was t minus 23, so we want to go back to the original variable of t. So I get 2/7 quantity t minus 23 to the 7/2 power. 46 times 2, 90 halves, 92 fifths, t minus 23 to the 5/2 power, plus 1058, which is 529 times 2 over 3 times that same t minus 23, this time to the 3/2 power right there. Okay, there it is. Very cool problem. Substitution that requires sort of an extra step where you have to come back and express this thing in terms of u, which you can do because of this relationship right here, your original substitution. Okay, hope this is helpful.